Hello everyone, good morning. Hello. Hi, how are you? Yes, good morning everyone. Good morning. So today we are going to talk about our some questions discussion. Okay, we are going to talk about some questions discussion. We are going to solve certain questions. Okay, so today I have taken questions from solid state. I have summarized the questions here. Okay, and we are going to talk about them, right? So please try and yes, please join fast. Yes, so today let's talk about. Hello, Ayushi, good morning. Can you hear me? Can you see the screen? Okay, very good. So today we are going to talk about some questions from solid state. Okay, we are going to talk about some questions from solid state. Yeah. So let's begin our session. Yes. Yeah. So the first question here is what? The number of hexagonal faces that are present in the truncated octahedron is. So here 2, 4, 6 and 8. First of all, we need to consider the structure of truncated octahedron. Okay. If you have known the structure of this, you will be easily determine how many hexagonal faces are present in this given molecule. Okay. So here you can see the structure of this given molecule. Yeah, there are how many hexagonal faces? See this structure. This is the 3D structure. This is the 2D structure I have shown. Here you can see 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 octahedron. Okay, these are the 8, not octahedron, sorry. These are the 8, what we can say that 6-membered ring. Okay, these are the 6-membered ring. 8 regular hexagons are present in this truncated octahedron. You can see 1, 2, 3, 4, 5, 6. These are the 6 square present in this given compound, right? In this given structure. So this truncated octahedron consists of 14-faced solid molecule. It consists of 14 faces, 6 square faces and 8 regular hexagonal faces. So here the question was, how many hexagonal faces are present in this given molecule, truncated octahedron? So what will be our answer? Answer will be option D, because here how many present in truncated octahedron formed by removing the 6 right square pyramid, 1 from each point of a regular octahedron. So from pyramid, you can form this truncated octahedron, and here you can see how many faces are present. 8 hexagonal faces are present in this truncated octahedron. Okay, don't get confused here. You should never get confused here. Okay, here ट्रंकेटेड ऑक्टाहेड्रॉन में हमारा मॉलिक्यूल इस तरह से है, जिसमें 6 स्क्वायर है और 8 क्या है हमारे हेक्सागोनल फेसेस. वेरी गुड. टोटल फेसेस आर हाउ मेनी? 14. 6 plus 8. Yes, everyone, is that right? Any doubts? Let's move on to the next problem. An element according to BCC structure has this many cells. The total number of atoms of the element in this cell will be. So you know that element, if present in a BCC structure, you know that number of atoms around BCC structure are how many? Present in the BCC structure are how many? Can you tell me how many atoms can accommodate in BCC structure? Total number of atoms for BCC? Yes. So here element is present in BCC structure which has this many unit cells. So we need to find out total number of atoms. So total number of atoms कितने होते हैं BCC में? 2 होते हैं. So 2 into these unit cells will give us the total unit cell present in this given BCC structure. So what will be the answer for this problem? See here, there are 2 atoms present in the BCC structure unit cell. That's why the number of atoms in this much unit cells will be 2 into this much. So what will be the answer? 24.16 into 10 raised to 23. That is option C. Yes, everyone, any doubt? Very simple problem was this. Okay, BCC structure, it contains 2 atoms for 1 unit cell. And how many unit cell were present? 12 into 10 raised to 23 unit cell were present. So how many total number of unit cell will be present? 2 multiplied by that much. Right? Any doubt? Okay, let's move on to the next. Which of the following statement is not true? So here we need to consider a statement which is not true about the magnetic properties. So you know that diamagnetic compound, paramagnetic compound, ferromagnetic compound, antiferro and ferrimagnetic substances. These are the different kinds of substances which are present. What is the diamagnetism? Diamagnetic substance is what which is weakly repelled by magnetic field, and they do not have any unpaired electrons. So diamagnetic means what? They are not repelled by any kind of magnetic field. Okay, they are weakly repelled by magnetic field. Next, they do not have any unpaired electron. Next, paramagnetic substances, you know, these are what? Attracted by the magnetic field and have unpaired electrons. Since they have unpaired electron, they are attracted by the magnetic field. They lose the magnetic moment in the absence of the magnetic field. Okay, if magnetic moment is not present, they lose their magnetic behavior. Ferromagnetic substances are which substances? They get attracted by the magnetic field and show permanent magnetism even in the absence of magnetic field. That is known as ferromagnetism. Substances, they are magnetic, they are attracted by the magnetic field, and due to the presence of magnetic field, they acquire a permanent magnetism in them even in the absence of magnetic field. Okay, antiferro are what? Have magnetic moment 0 due to the compensatory alignment of magnetic moment. So they show the magnetic moment, but the magnetic moment is opposite direction. One is in the up direction, then another one will be the down direction, and due to which the magnetic moment get cancelled by each other. Compensatory alignments of magnetic moment, due to which they acquire the 0 magnetic moment. Okay, and they are known as antiferromagnetic substances. Ferri, what is the meaning of ferromagnetic substances? They have net dipole moment due to unequal parallel and anti-parallel elements. So here also there is alignment of magnetic moment, but sometimes what happens is there is unequal alignment of these magnetic moments, and due to which the molecule have the magnetism, and which is known as a ferromagnetic substances. Now here question was what? Which of the following statement will be not true? So paramagnetic substances are weakly attracted by magnetic field. Yeah, just now we have seen that paramagnetic substances are weakly attracted by magnetic field. So this statement is true statement. Second statement is what? Ferromagnetic substances cannot be magnetized permanently. So right now we have seen ferromagnetic substances are attracted by the magnetic field and they show permanent magnetism even in the absence of magnetic field. So ये जो second statement है हमारा, the substances which cannot get what? Which cannot get magnetized permanently, this is not correct. Okay, that is not true. Third, the domains in the antiferromagnetic substances are oppositely oriented with respect to one another. Yeah, this is again true. Fourth one is what? Pairing of electrons cancels their magnetic moment in diamagnetic substances. Yeah, this is also true. Why diamagnetic substances do not have any magnetic moment? Because the electrons are completely paired, and due to their pairing, they cancel the magnetic moment of each other, and that's why they do not show any kind of magnetic moment. Right? Any doubt in this? So what will be correct option here? Option B. Okay, ferromagnetic substances can be magnetized by applying magnetic field to it, and the magnetic property persists within it even after the removal of magnetic field. So magnetism permanently रह सकता है यहाँ पे, right? So our option B is not true statement, and that is our correct answer here. Any doubt? Are you getting this? Any doubt in this? Yes. Okay, let's move on to the next problem. Yeah. What will be the yeah. So here we need to consider the problems which require determination of the formula or stoichiometry for a given solid, right? So before doing this, let's consider let's recall these concepts. Okay, in CCB structure, you know the number of octahedral weights are 4 and number of tetrahedral weights are 8. You know that how many number of atoms are present, multiply it by 2, you get tetrahedral and equal to that are what? Octahedral. That is our already discussed topic point. Again, we have seen these ionic solids, rock salt solid, CCS-Cl type solid, zinc blade, fluoride, and antifluoride. Remember the positions of each and every ion. Na plus is present where? Na plus is present at the CCP or FCC lattice. Means what? All the Na plus ions are present at the FCC or CCP present. Okay, and Cl minus are surrounded by, okay, the and Na plus ions are also present at the octahedral voids. Cl minus ions के जो octahedral void form होंगे वहां पे Na plus ion present है, and the tetrahedral voids in NaCl are what? Completely vacant. Are you getting this? Next, CCl in which Cs, that is cesium, is what? Present at the center of the given cell, and Cl minus are present in the BCC arrangement. Zinc blade, what is happening? Zn2 plus are present at the CCP arrangement, and S2 minus are present at what? The what we can say it, they are present at around the zinc. Okay, similarly is the case with fluoride and then with the antifluoride. So we need to remember here coordination number of each, and we need to remember here the position of each and every, what we can say, that element. Okay, next, now if we want to determine the formula for a given compound, then that time we should consider the cell structure. Okay, then we should consider the cell structure. So here in a solid AB having the NaCl structure, A atom, okay, AB का स्ट्रक्चर कैसा है? NaCl जैसा. NaCl का स्ट्रक्चर कैसा है? CCP हम लोग बोल सकते हैं या फिर FCC स्ट्रक्चर बोल सकते हैं. A atom occupies the corners of the cubic unit cell. If all the faces centered atom along one axis are removed, then the resultant stoichiometry of the solid will be. So यहाँ पे what is happening? A atom is present at the corners of the unit cell. So how many corners are present? 8 corners are present, and at all 8 corners, the atom is contributes 1/8 of its part. So around 1 A atom is present in the given unit cell. If all the face centered atom along one of the axes are removed, suppose there is an axis, okay, this is our crystal unit cell, okay, along one axis, suppose what has happened, the face, हमारे जो फेस पे प्रेजेंट एटम्स, दे आर रिमूव. सपोज along one axis, suppose this is one axis, okay, we know that x, y and z axis, okay, suppose along one axis, ये एक्सिस अगर हम लोगों ने कंसिडर किया तो यहाँ पे ये एक फेस आती है और ये एक फेस आती है. तो ये जो हमारे दो सेंटर्ड में, ये अगर हम लोगों ने रिमूव कर दिए, so what will be the stoichiometry of this given compound? Then what will be the stoichiometry for this given compound? So what will be the stoichiometry for this given compound? See here, structure is having FCC. So corner पे क्या है हमारे A present है, और at the face कितने present है? दो तो निकल गए, दो face में जो present है वो निकल गए. तो at every face a given atom contributes half. Okay, at every face given atom contributes half. So that's why here what will be the total atom present? 2 atoms are present. So atom B are present at face, and B removed, okay, 2B are removed from one axis in the given unit cell. That's why here 2B atoms are present with respect to one unit cell, and 1A atom is present with respect to one unit cell. Any doubt in this? So the answer will be what? EB2. Right, everyone? The answer will be what? EB2. Yes. Next, how many unit cells are present in a cube-shaped ideal crystal of NaCl of mass 1 gram? So here we have given the mass, we have given the atomic masses, and we need to find out how many unit cells will be present. Okay. So as we know unit cells, how many unit cells are present in NaCl structure? So it's have FCC arrangement, right? It have FCC arrangement. In FCC arrangement, how many atoms are present? Actually, per unit cell, 4 atoms are present per unit cell. That we know. But here, what is given to us? So here given is what? How many unit cells will be present? So उसमें कितने ज़्यादा unit cells present होंगे? So let's find out the answer. So number of formula units we need to calculate here. ठीक है? कितने formula units present होंगे? 1/58.5. So what is the mass of NaCl? NaCl का mass you can calculate 35.5 for chlorine and add sodium's 23. So it will be equal to 58.5. Okay, so Avogadro's number divided by the its molecular weight, if you are going to get the formula units present in the given unit cell. As we know, in NaCl, per unit cell, how many atoms are present? 4. 4 atoms are present means what? 4 Na plus are present and 4 Cl minus are present. So we need to divide the formula unit by the number of atoms. So when we divide it now, we get this many unit cells are present in the cube-shaped ideal crystal of NaCl. So kitne present hai? 2.57 into 10 raised to 21. That is option C. Right? Any doubts? Very different problem. Okay, different problem था. यहाँ पे हम लोगों को unit cell पूछे थे, and in this way we need to calculate them. Yeah, any doubts? Yeah, let's move on to the next problem. Each rubidium halide crystallizing in the NaCl type of lattice has a unit cell length. So we have given the unit cell length 0.30 angstrom, greater than that for corresponding potassium salt, that is 1.33 angstrom of the same halogen. Hence, ionic radius of rubidium plus will be. So here, rubidium halide crystallizes in NaCl type lattice, means HC lattice, it is getting converted. And we need to determine what will be the ionic radius of the ion, that is cation, present in that given lattice. Okay, so let's consider this. Increase on length, increase in the radius will be what? 0.30 angstrom unit length, right? What has happened? Each rubidium halide crystallizes in the NaCl type lattice has a unit cell length 0.30, greater than that of its corresponding. तो इतना ज्यादा क्या हो रहा है? Increase हो रहा है. पहले कितनी थी? 1.33 थी. Now it has become added with 0.30. Okay, so what will be the actual radius? अगर 0.30 से वो बढ़ रही है. So this 0.30 angstrom unit length. So you know that radius is due to what? 2 atoms, right? We measure the radius with respect to 2 atoms. Okay, so that's why what will be the radius for one atom? One atom के लिए radius कितना होगा? 0.30 divided by 2, and 1.33 was its initial. I have added it here. So what will be the total length? Total radius 1.48 angstrom. So here the answer will be option B. Yes, any doubts? See, the problem was different. Okay, yeah. Next, let's move on to the next problem. A cubic unit cell of metal, molar mass is given to us, has edge length this much, its density is this much. The type of unit cell is, so whether it is primitive, face-centered, body-centered, or end-centered. So how we can determine that, whether the molecule is face-centered or body-centered or end-centered? So we know the formula for density. What is the formula for density, everyone? Density is equal to Z into M divided by what? Avogadro's number Na into what is the cell length? That will be the cube of that, right? This is the formula for density. Now we have given density, we have given the molar mass, we know the Avogadro's number, we know the edge length here, 362 picometer. We can easily find out how many number of atoms are present in the given unit cell, right? How many number of atoms are present in the given unit cell. As soon as we get to know how many number of atoms are present, we can easily say which type of unit cell it may be, right? Whether it is primitive, face-centered, body-centered, or edge-centered. So see, answer here, density is equal to Z by M, Na, A cube. So this A value was given in picometer, I have converted into meter, and later on I have converted into centimeter, right? So this is our A, final A. Now, molecular weight is given 63.55 gram per mole. Density is given gram per centimeter cube. So everything is gram per mole centimeter cube, and A is also in centimeter. So we need to find out the Z. So all putting values, by putting all the values, you can see here, I am getting Z value as equal to 4. So what is the atom or unit cell which contains number of atoms as 4? So you know it, the lattice will be what? FCC. So metal crystallizes in what? FCC. So this will be our correct answer here. Yeah, everyone, any doubts regarding this? Are you understanding now? Okay, let's move on to the next problem. Which of the following statements about amorphous solid is not true? So here for amorphous solid, which one is not true? On heating, they may become crystalline at a certain temperature. They may become crystalline on keeping for a long time. Amorphous solids can be molded by heating, and another one is they are anisotropic in nature. So what will be the answer here? Which is not true? Yeah, can you tell me for amorphous substances which is not true? Amorphous solids are what? Isotropic. Yes, they are what? Isotropic in nature. Amorphous solids are isotropic in nature because it has no long range order and any physical property will be same for all characteristic feature of crystalline solid. So they are anisotropic जो है statement हमारा. This is not true because they are what? Isotropic. Isotropic means what? They can no longer have range, no long range. They do not have a long range order and any physical property will be same and all characteristic feature for this given crystalline solid. Okay, all the statements above are true. So we can say that on heating, they may become crystalline at a certain temperature. So this is true. They may become crystalline on keeping for a long time. True. Molded on heating. True. This is true. This is false. And that's what we need to find out. Anisotropic nahi hote, they are isotropic. Next, a unit cell of binary alloy compound of A and B metals has a CCP structure, that is means FCC structure. Atom A occupying the corners and B atom occupying center of each face of the cube. If during the crystallization of this alloy in the unit cell, 2A atom are missing, the overall composition of the unit cell will be. So here we need to consider that A was present at the CCP structure. A atom were present at the corners of a given CCP structure. But if during this crystallization of this given metal, what happens is that A atom becomes missing. How many? 2 A atoms become missing. So what will be the composition of a given unit cell? For unit cell, what will be the composition? So what will be the composition here? You can see permitted coordination number for CCP is 8, right? 8 is the coordination number for FCC or CCP structure. But here 2 atoms are missing. So since 2 atoms are missing, contribution per A will be what? 6 into 1 by 8. So it will be 6 by 8, right? And contribution by B will be what? 6 into half because all B atoms are present at the faces. So that's why they will be total 3 B atoms per unit cell. Okay. So 6 by 8 atoms of A and 3 atoms of B. Every time when we used to write for FCC, 8 atoms are present at the corner and for each atom, the contribution is 1 by 8. That was the 1 by 8 contribution. But here, 2 atoms are missing. So 8 minus 2, 6 atoms will be present. So if 6 atoms are present and whose contribution is 1 by 8, so overall atoms are what? 6 by 8. So I am writing A 6 by 8 and B is what? 3. So just converting this into the इंटीजर नंबर. ओके 6 by 8 को हम लोग क्या करेंगे 8 से डिवाइड कर देंगे, 8 से मल्टीप्लाई कर देंगे 6 और b को भी मल्टीप्लाई करो 8 से, 8 3 are 24. So our overall composition of the compound will be what? A6B24. Right? Any doubt in this? Very simple problem. The asking of question is different, right? Yeah, very good. Next problem. Sodium metal crystallizes in BCC arrangement with the interfacial separation between the atoms at the H 53 picometer. The density of the solid. So this is very simple problem, right? We just need to determine the density of a given compound. Okay. So see here, here I have shown the structure also. So the spheres at the corners are not touching each other. Sodium crystal किसमें है? BCC arrangement में. With the interfacial separation between the atoms at the edge length we have given, that is 53 picometer. Okay, edge length means what? A minus 2R, 52. Okay, so in BCC structure we know the relation between radius and what we can say edge length. 4R is equal to root 3. So you can convert it into 2R. 2R is equal to root 3 by 2A. Right, just divided it by 2. So we need to put the value for 2R here. So A minus 2R का value क्या है? root 3 by 2A. And that is equal to how much? 53. So just rearrange this, you will get value for A. A is equal to what? 395.6 picometer. Okay, so convert this into meter, into centimeter and match with the respective, what we can say that A value. Okay, ये मिल गया हम लोगों को A value. Now here what we need to determine density. So in order to calculate density, you know the formula Z into M divided by Na, that is Avogadro's number, into A cube. So put all this value here. What will be the answer? When putting the values, a number of atoms will be 2 because it is what? BCC arrangement, not FCC. Even the sodium is written here, the arrangement is BCC. See, you can get tricked here. Okay, 23 is what? Mass of the sodium atom. Na are the number of Avogadro's number. 3.956 is the A value into 10 raised to minus 24. 8 3s are 24. And 8 into 3 is 24, and like this way you get the answer this much, 1.23 gram per cc. That is option A. That is option A. Okay, so this is our answer. Yeah, any doubt in this? Simple problem was this, but here what we have given, age length was given. ठीक है, age length हम लोगों को दिया हुआ था 53 picometer. Okay, next. Ferrous oxide has cubic structure. So it is having cubic structure. The age length of the unit cell is 5 angstrom. So A value is given, that is 5 angstrom. The density of the oxide density is also given 4 gram per centimeter cube. The number of Fe2 plus and O2 minus ions present in each unit cell will be. So here we need to determine the Z value again. So Z value determine करना है. Z का formula put कीजिए. Z is equal to density into Avogadro's number into what? V divided by M. So here what is V? V is what? You can first of all determine A value, converted into centimeter, mass को convert कीजिए ग्राम पर मोल में. N0 क्या है हमारा? N0 है हमारा Avogadro's number, right? All you know. V क्या है हमारा? Volume. Volume क्या होता है? AQ, right? So just put A का value, and when you put all these values, na, you will get Z is equal to 4. And when Z is equal to 4, what happens? 4 molecules of ferrous oxide are present, which gives Fe2, 4 Fe2 plus and 4 O2 minus ion. Hence, which type of compound will be this FCC structure? So 4 Fe2 plus and 4 O2 minus are present here, and this will be our answer. देखिए यहाँ पे हम लोगों को क्रिस्टल कैसा होगा वो ने पूछा था. How many ions will be present per unit cell? So you know in FCC 4 Na plus and 4 Cl minus are present. Similar as 4 Fe2 plus and 4 O2 minus ions will be present here in this given molecule, right? Any doubt in this? Very good problem. Yeah. Next, a binary solid is given, has a zinc blende structure with B minus ion constituting the lattice and A plus ion occupying the 25% tetrahedral holes present in the given solid. So the formula of the solid will be, so you know, as A plus ions are occupying 25% of what? Tetrahedral holes. Okay, 25% of our tetrahedral holes. So here, in order to calculate this, the number of B minus ions present in unit cell are what? Zinc blende structure, B minus ions are occupying consisting the lattice. Okay, तो यहाँ पे हमारा जो zinc blende structure है उसमें क्या है? हमारे lattice में 8 atoms present है, which contributes 1 by 8, and 6 atoms are present, which contributes half. So total B minus ions present per unit cell are what? 4, right? A minus ions कहाँ पे present है? A minus ions occupies 25% of the octahedral holes, right? So what will be that? 8 into 25 divided by 100 is equal to 2. So B minus to A plus का रेशियो कितना होगा? 2:1, क्योंकि 4 by 2 हो जाएगा. B minus का क्या होगा? 4 और A plus का क्या होगा? 2. So overall this is what? 2:1. So we can say that the formula for a given molecule will be AB2. Right, everyone? Any doubt in this? Okay, let's move on to the next problem. Yeah. Iron exhibits BCC structure at room temperature, right? Next guy, above 900 degrees centigrade, it transforms to FCC structure. The ratio of the density of iron at room temperature to that at 900 degrees Celsius, assuming molar mass and atomic radius of iron remains constant with the temperature. So see, recent NEET में ये क्वेश्चन पूछा गया है, आयन का स्ट्रक्चर कैसा है? BCC स्ट्रक्चर है. आयन इज हैविंग BCC स्ट्रक्चर. above 900 डिग्री सेल्सियस BCC से वो कन्वर्ट हो रहा है HCC में. रेशियो ऑफ डेंसिटी ऑफ आयन एट रूम टेम्परेचर टू दैट ऑफ 900 डिग्री से, रूम टेम्परेचर वो BCC में था, ठीक है, रूम टेम्परेचर में था वो BCC में. BCC to FCC का जो हमारा डेंसिटी का रिलेशन होगा, what will be that? That was asked here, right? That has asked here. So yesterday only, the day before yesterday, we have also solved the density ratio. Yeah, you know what will be the formula for this? Density is equal to, density for BCC will be equal to, what will be that? Z upon Z of BCC divided by what? A cube of BCC, because all other things will be constant, same. Okay, Z for FCC will be what? It will be Z into FCC divided by A cube of FCC. This will be the formula we need to use, right? So see, the density of unit cell, you know the density का formula, right? Avogadro's number पता है, radius पता है, ठीक है? तो radius पता होने के बाद BCC में radius क्या है? Z is equal to 2. यहाँ पे Z equal to 4 होने के कारण radius हमारे √3/4. तो मैंने क्या किया? A का वैल्यू निकाल लिया 4R upon √3, और यहाँ से भी मैंने A का वैल्यू निकाल लिया 2√2. So here A वैल्यू हम लोग क्या पुट करेंगे in this given formula? For FCC, the A value will be equal to 2√2R. And for BCC, A value will be 4r by root 3. Put कीजिए ये value इस formula में. What will happen? So here you can see BCC by FCC by substituting this value 2 into m by this much, 4 into m by this much. Okay, number of atoms. ये Na क्या है हमारे सेम ही होंगे, तो ये बाद में क्या हो जाएंगे, कैंसिल हो जाएंगे. ठीक है, by putting these values ना, you can see what things are going to cancel here. 16, 16, 64, what will be that? 4, right? 2 into 2 by 2 into 4. So यहाँ पे एक जगह 2. So with this, what you are getting this ratio 3 by 4 under root of root 3 by 2. So what is that option, A or B? So that is the option A. Right? यहाँ पे सिर्फ the statement, the question asking thing is different, but answer and formulas you know, right? 3 by 4 into root 3 by 2. That was the answer. And in this way, you need to solve this problem. Any doubt in this? Very good problem actually. A का value निकालो और A का value put करो. Sometimes if you have given A value, directly put that A value. Okay. If you have not given the A value, convert or use the value from R value. ठीक है? Use the concept of R. क्योंकि radius तो same होने वाली है. ठीक है? For both, because the molecule is what, same. Right? Next problem. In which of the following structure coordination number for cation and anion in the packed structure will be same? So here we need to consider which of the following structure coordination number for cation and anion in the packed structure will be same. So same कब होगी? So you know Cl minus ions from FCC lattice and Na plus ions occupy all the octahedral voids of the unit cell. Cl ion from lattice and F minus ion occupy all the 8 tetrahedral voids of the unit cell. O2 minus ion form FCC lattice and Na plus ion occupy all the 8 tetrahedral voids of the unit cell. And H2 minus ion form FCC lattice and Zn2 plus ions go into alternate tetrahedral voids of the unit cell. तो इनमें से कौन सा जो हमारा स्ट्रक्चर है वो मैच हो रहा है? कैटायंस एंड अनायंस पैक्ड स्ट्रक्चर विल बी द सेम. ठीक है, तो NaCl क्रिस्टल जब हम लोग बात कर सकते हैं उसको हम कहते हैं रॉक सॉल्ट स्ट्रक्चर which have FCC or CCP arrangement, right? Here what happens is that Cl minus ions are present at FCC lattice point and face center. Okay, Cl minus are present at CCP at the corners and at the faces of a given lattice. And Na plus ions are occupies all the octahedral voids. Right? We know this. All Na plus ions are present at the octahedral voids of the unit cell. So what will be the coordination number for Na plus? How many octahedral voids are formed there? 6. And coordination number of Cl minus is again what? 6. So similarly, coordination number for Zn2 plus and H2 minus are what? 4. So यहाँ पे ये जो हम FCC lattice दिया हुआ है ना, यहाँ पे Zn2 plus ion go into alternate tetrahedral voids of the unit cell. So here what is the correct answer? So Cl minus ions form FCC lattice and Na plus ion occupy all the tetrahedral unit cell. So this is our correct answer A. Okay, any doubt in this? Let's move on to the next problem. Yeah. Can you tell me what will be the answer? A solid compound contains X, Y, Z atoms. So here how many atoms are there? 3 atoms are there. Okay. In a cubic lattice with X atoms occupying at all the corners, Y atoms are in the body centered and Z atoms at the centers of face of the unit cell. What will be the formula for a given compound? So you know how to solve this. X is present at the corners. You know, at the corner of unit cell, the contribution is 1 by 8. Right? Y atoms are present at the body centered. At the body centered, atoms contribution is complete, whole atom is present completely. Right? And Z atoms are present at the centers of faces. So at the face, how many contribution is done by one atom? Half contribution is done. So how many X's and how many Y's and how many Z's will be present here? These atoms will be present. See, at the corner, number of unit cell will be 1 by 8 into 8 atoms present, 1 by 8, so 1 atom. Okay, body centered, total 1 atom will be present, X, Y, and Z. And for Z, 6 faces are present. So due to contribution of 6 faces, that is half. So X, Y, and Z, 3. Okay, so X, Y, Z, 3. So option 2 is correct answer here. Any doubts? Very simple problem. You understand this? Hello, everyone, understand this? Right. Let's move on to the next problem. Structure of mixed oxide is CCP. Okay, the unit cell of mixed oxide is composed of oxide ions. 1/4 of the tetrahedral voids are occupied by divalent metal and the octahedral voids are occupied by monovalent metal, the formula for the oxide will be. So here we need to determine the formula for a given oxide. So how we can do that? So just put all the values in the given. हम लोगों ने ये जो प्रॉब्लम सॉल्व की ना उसी तरह से ये भी प्रॉब्लम हम लोगों को सॉल्व करना है. देखिए, वी नो दैट इन क्यूब क्लोज्ड पैक्ड स्ट्रक्चर व्हाट इज हैपनिंग, द नंबर ऑफ एटम्स आर n, octahedral voids are n and tetrahedral voids are 2n. So यहाँ पे octahedral and tetrahedral voids are used. So here number of a plus 2 ions are present. How many are that? 2n by 4. And b plus कितने प्रेजेंट होंगे? n. और ऑक्साइड कितने प्रेजेंट होंगे? n. क्यों? क्योंकि यहाँ पे दिया हुआ है डाइवेलेंट मेटल है a and the octahedral voids are occupied by the monovalent atom b. ठीक है, टेट्राहेड्रल वॉइड किसने ऑक्यूपाई किए हैं? टेट्राहेड्रल वॉइड्स वेर ऑक्यूपाइड बाय A+, ऑक्टाहेड्रल वॉइड्स वेर ऑक्यूपाइड बाय B2+, एंड हमारा जो ऑक्साइड है वो कहाँ पे प्रेजेंट है? ऑक्साइड इज प्रेजेंट एट द कॉर्नर्स ऑफ ईच ऑक्साइड. ओके, मेटल ऑक्साइड इज कंपोज्ड ऑफ ऑक्साइड, फोर्थ ऑफ द टेट्राहेड्रल वॉइड्स आर ऑक्यूपाइड बाय डाइवेलेंट. ओके, यहाँ पे दिया हुआ है ऑक्साइड कहाँ पे प्रेजेंट है? कॉर्नर्स पे प्रेजेंट है. इसलिए इस तरह से मैंने वो क्या कर लिया? डिस्टिंग्विश कर लिया. नाउ A plus 2 is to B plus is to 2 minus. So how many are there? N by 2 is to N is to 1. So N by 2 half, 1. Half, 1, 1. So let's make the integer value 1, 2, 2. That is A, B2, O2. A, B2, O2. What is that? A, B2, O2, option 4. Understanding this? Very simple concept, but most of the time, you need to determine the formula for a given molecule. Okay, again similar type of question is there. Lithium metal crystallizes in a body centered cubic crystal if the length of the side of the unit cell of lithium is this much. Atomic radius of lithium will be, you know the formula for density, right? Use the formula, as well as you can use the formula for R is equal to what? √3/4a. हम लोगों को a का वैल्यू दिया हुआ है, easily you can determine the radius. So this unit was what? BCC. For BCC, you know what is the value for R? R is equal to √3/4a. Directly use, put the value for A, you will get answer 151.8. Very simple problem, right? Very simple problem. Next, silver has density. Silver का density दिया है, number of silver atoms on a surface of an area can be expressed in scientific notation like this. What is the value of X? Here जो value X है ना 10⁻² वाला, इसका वैल्यू क्या है हम लोगों को पूछा है. So very interesting problem again. You know the density is given, that is what 10.5 gram per centimeter cube, right? What is the density? This much is the density, gram per centimeter cube. Silver atom is crystallizes in FCC unit cell where 4 atoms are present per unit cell. So you know the formula for density, Z into what? 1Z, that is molecular weight, divided by Avogadro's number multiplied by A cube. You know the density, put the values, you will get A cube का value. What is the A cube का value? ये value हो गया. लेकिन we need to find out A का value. What is A? 4 into 10⁻⁻8 centimeter. Convert it into meter, क्योंकि हम लोगों को क्या पूछा? साइंटिफिक नोटेशन में करना है ना, ठीक है? तो हम लोगों को यहाँ पे सरफेस एरिया का वैल्यू भी दिया हुआ मीटर क्यूब, मीटर स्क्वायर में. So we need to convert centimeter to meter. तो सेंटीमीटर को मीटर में कन्वर्ट करते वक्त you need to do this 4 into 10⁻⁻10, right? So surface area आप लोगों को दिया हुआ है 1.6 into 10⁻⁻19 meter square, right? So number of unit cell on 10⁻⁻12 meter square surface will be how much? 10⁻12 divided by this will be the surface area. तो आप लोगों को मिल गया number of unit cell इतने. There are 2 atoms on face of unit cell. So 2 into number of unit cells. So this much will be the answer and value for X will be 7. Yeah, are you getting this? Different type of question. Okay, asking is very very different. Value of X कितना है? 7 है. समझ में आया सबको? The problem is this way we need to find out about the value of X. ये 1.6 कहाँ से आया बच्चों? क्योंकि ये क्या है? A का वैल्यू 4 है. 4 का स्क्वायर कीजिए 16 होगा, ठीक है? 10 into 2 -20 होगा. -20 के बजाय मैंने यहाँ पे सिर्फ -19 लिखा. That's it, right? Yeah. Next, total volume of atoms present in a FCC cubic unit cell of metal is. We need to find out the volume. So we need to find, in order to find out the volume, you know the formula. Since volume of an atom is what? Spherical in space shape. So the formula will be what? 4/3 pi r cube. 4/3 pi r cube. Right? do you know total volume of atoms, right? So here the volume is for one atom. How many atoms are present per given unit cell? 4 atoms are present. So multiply it by 4. What will be the answer? 16 by 3 pi r cube. So 16 by 3 pi r cube, this much. वन एटम का होता है 4/3 pi r cube. FCC में कितने एटम्स प्रेजेंट होते हैं? 4. Similar problem can be formed with the BCC. Similar problem can be formed with the simple cubic unit cell, right? Yeah, next. The age length of FCC centered cubic unit cell is this much. If the radius of the cation is this much, the radius of the anion will be. So you know the formula, radius ratio formula, right? So you know if centered में क्या होता है? The age length of the unit cell is what? A is equal to R plus 2R plus R. So this is the age length for a given unit cell. So radius of cation is R and capital R is the radius of anion. So you can easily find out from this formula. So determine कीजिए. Remember this given formula. Okay, it will be easy for you to calculate. R क्या है? cation का है और R क्या है? anion का है. Radius. Okay, any doubts? Next. Schottky defect in crystal is observed when density of the crystal is increased, unequal number of cations and anions are missing from the lattice, an ion leaves its normal site and occupies an interstitial site, and equal number of cation and anion are missing from the lattice. So this is very simple problem. Can you tell me the answer? Schottky defect in a crystal is observed when density increased होती है क्या Schottky effect में? नहीं, that is wrong. Unequal number of cations and anions are missing from the lattice. Whether this is the case? Yes, can you tell me whether this is the case? No. Next, an ion leaves its normal site and occupies interstitial site. So this is also not happening. Equal number of cation and anion are missing from the lattice. Yeah, this is the correct answer. So option D is what correct. In Schottky defect, equal number of cations as well as anion are missing from the lattice, so the crystal remains neutral. And such a defect is more common in highly ionic compounds of similar cationic and anionic size like NaCl. So this is what our Schottky effect. Very, very important. Any doubts? Okay, let's move on to the next problem. The high density of water compared to ice is equal. So yeah, do you know why even though we put ice into the water, what happens? High density of water compared to ice float on the water, right? Why is that? Because water have more density as compared to ice. Why? Due to dipole-induced dipole interaction, induced dipole-induced dipole interaction, hydrogen bonding interaction, and dipole-dipole interaction. So why is this is happening in terms of water? Because it shows high hydrogen bonding. So due to the polar nature of water, water molecules are held together by intermolecular hydrogen bonds between the molecules. And the structure of ice is what? Open, with a large number of vacant spaces, and thus density of ice is lesser as compared to the density of water. So when you have a glass of water now, and when you put ice into that, the ice floats on the water. Why that is happening? Because the density of ice is less, because there presence of vacant spaces in the structure. But in the water molecule, there is a high hydrogen bonding present, intermolecular hydrogen bonding. Each atom is binded to another atom with the hydrogen bonding, and due to which its density is more as compared to ice, right? Yeah, next. The for two ionic solids, CaO and Ki, identify the wrong statement. So we have given, we need to consider two ionic solids, okay, and which statement is wrong. Okay, CaO has high melting point. Lattice energy of CO is much larger than that of Ki. Ki has high melting point and soluble in benzene. So the statement here, this statement is wrong. Okay, since it is ionic compound, it will be soluble in ionic solution. Okay, polar solution. Benzene is not molar solution. So Ki being an ionic compound, benzene is not, and that's why it cannot be soluble in benzene. Other things are true. Other statements are true. This is a wrong statement. Okay, any doubts in this? Yes, let's solve next problem. Number of atoms in 100 gram of FCC crystal lattice with density is this much and cell age equal to this much. Okay, कितने number of atoms यहाँ पे present है? अगर 100 gram का FCC crystal lattice है, whose density is 10 gram per centimeter cube and cell age is equal to 100 picometer will be. So we know the formula of density. You can easily calculate the density. right? Mass is given 100 gram, density is given 10, age length is given, I have converted into centimeter. Volume of the unit cell, you can easily determine the volume from the age length, L value दिया हुआ है, उसका क्यूब कीजिए, 10⁻⁻24 सेंटीमीटर क्यूब आपको मिल जाएगा. वॉल्यूम ऑफ 100 ग्राम ऑफ एलिमेंट विल बी व्हाट, मास अपॉन डेंसिटी. मास कितना है, 100 ग्राम है, डेंसिटी हुआ है 10, वॉल्यूम विल बी व्हाट, 10 सेंटीमीटर क्यूब. द नंबर ऑफ यूनिट सेल, हाउ यू कैन कैलकुलेट, 10 जो है हमारा वॉल्यूम, डिवाइड किया उसको 10⁻24 से, वॉल्यूम ऑफ यूनिट सेल से. Volume of 100 gram of element divided by volume of unit cell, you get the number of unit cell 1 into 10⁻25. But you know, in FCC, how many atoms are present per unit cell? 4 atoms are present per unit cell. So in 100 gram, how many atoms will be present? 4 into this much. 4 into this much. So how many? 4 into 10⁻25. Are you getting this? Volume हम लोगों ने यहाँ पे निकाला. नंबर ऑफ यूनिट सेल्स हम लोगों ने यहाँ से निकाले 100 ग्राम. ठीक है, 100 जो हमारी डेंसिटी, वॉल्यूम ऑफ, आई विल राइट हियर, वॉल्यूम ऑफ 100 ग्राम ऑफ एलिमेंट डिवाइडेड बाय व्हाट, वॉल्यूम ऑफ यूनिट सेल. वॉल्यूम ऑफ यूनिट सेल. ठीक है, 100 ग्राम में कितना है वॉल्यूम, हमारा 10 था, और यूनिट सेल का वॉल्यूम कितना था, 10⁻⁻24 था. सो जस्ट पुट ऑल दिस वैल्यू, वी गेट द नंबर ऑफ यूनिट सेल. यहाँ पे नंबर ऑफ यूनिट सेल. राइट एवरीवन? तो हमारा आंसर है दिस वन, सी ऑप्शन. या नेक्स्ट प्रॉब्लम, आयोनिक सॉलिड्स. या वी नीड टू टॉक अबाउट आयोनिक सॉलिड्स हियर. Ionic solids with Schottky defect contain their structure. Yeah, Schottky defect, just now we have talked. Do they have cation vacancies only? No. Do they have cation vacancies and interstitial cations? Yes. Can you tell me the answer? I'm awaiting. Okay. You can tell me the answer for Schottky defect. Anyone? Ritu, Sushant, can you tell me the answer? Very simple problem. Cation vacancies only. Cation vacancies and interstitial cations. Equal number of cation and anion vacancies. So this is our correct answer, C. Okay, everyone, are you getting this? Do you understanding this? Okay, in Schottky defect, what is happening? Equal number of cation and anion are missing, and that's why density remains same. Okay, it is possible only for high ionic solids. Okay, and this is known as Schottky defect. Next, a pure crystalline substance on being heated gradually first forms a turbid liquid at constant temperature, and still at higher temperature, turbidity completely disappears. The behavior is a characteristics of substance forming allotropic crystals, liquid crystal, isomeric crystal, and isomorphous crystal. So which type of compound will show such a type of behavior? Allotropic crystal दिखाएगा, liquid crystal, isomeric or isomorphous crystal. So here I'm going to explain you about the liquid crystal. So what does liquid crystals do? Liquid crystals on heating first becomes turbid, and then on further heating, the turbidity of such crystals completely disappears. Okay, so here our answer is what? Liquid crystals. Okay, our answer is what? Liquid crystals. Right? Okay, let's move on to the next problem. Doping. So on doping of germanium metal with a little of indium or gallium, one gets which type of semiconductor? N-type, P-type, insulator, or rectifier? You know, we have talked about this. Yeah, we have talked about the doping. We dope group 14 elements with either group 13 wala or either group 15 wala. If our element is here from germanium or silicon, okay, they are good conductors of electricity. If we dope them with 13 element, what happens? There is a remaining one electron here. क्या रिमेन होता है? एक इलेक्ट्रॉन रिमेन होता है, इसलिए ये निगेटिवली चार्ज होते हैं. निगेटिवली चार्ज होते हैं, इसलिए इनसे जो सेमीकंडक्टर्स फॉर्म होते हैं, दे आर नोन एज एन टाइप सेमीकंडक्टर. हियर होल इज रिमेनिंग, राइट? होल इज रिमेनिंग, and due to the remaining of hole, positive hole is present. Okay, and due to the positive hole is present, P type of semiconductor is formed. Right? So here with a little of indium or gallium. So gallium किस element group का element है? 13 का या 15 का? Yeah. Yes, tell me. इंडियम इज विच टाइप ऑफ सेमीकंडक्टर? इंडियम से अगर हम लोगों ने जर्मेनियम को डोप किया तो यस, आई एक्सप्लेन यू राइट नाउ, कैन यू टेल मी द आंसर? या yes, what will be the answer everyone? Okay, so here what will be the answer? P type of semiconductors when are doped due to what? Metal deficiency defects by adding impurity containing less electrons. Germanium belongs to group 14 and indium to group 13, and hence doping of the type will be P type because यहाँ पे hole निर्माण होंगे और this type of doping will be giving us what? P type semiconductor, क्योंकि 14 को किससे डोप किया हम लोगों ने? 13 से। 14 को किससे डोप किया हम लोगों ने? 13 से। ग्रुप 14 जर्मेनियम, इंडियम क्या है हमारा? ग्रुप 13, एंड दैट्स व्हाई आवर आंसर विल बी व्हाट? P type semiconductor, right? Any doubt in this? Yes. Okay, let's move on to the next problem. समझ में आया सब लोगों को बच्चों? Yes. Any doubt in this? Next, move on. In fluoride structure, the coordination number of Ca2 plus ion is. So this is very simple. We have talked about the fluoride structure. In fluoride structure, what is the case? In fluoride structure, coordination number of Ca2 plus and F minus is what? Ca2 plus का 8 होता है और F minus का 4 होता है, राइट? Ca2 प्लस का कितना होता है? 8 होता है और F माइनस का 4 होता है। तो यहाँ पे हमारा आंसर आ जाएगा C, और Ca2 plus the coordination number will be 8, right? Any doubt regarding this fluoride structure, anti-fluoride structure? Try to remember all these things, right? So this is all about today's lecture. We have talked about the various problems regarding the solid state chapter. If you have any doubt, you want to discuss any topic with me, you can message me. Okay, you can reply in the chat box and I'm going to prepare that topic for you. If you have any special request of topic, you can tell me. Yes. Yeah, so thank you so much for joining in for today's lecture. If you have any topic in your mind, you can tell me. Okay. So we are going to talk another topic tomorrow. Let's meet tomorrow again. Thank you so much.